Chapter 5 covers ratios and proportions, and several sections to that. 5.1 is the introduction, and then ratios actually mean something, like in terms of unit prices, and then we're going to talk about proportions, what that is, and then we have the application of proportions, and then we have some geometric applications. Section 5.1 is about we look at fraction notation for ratios, and then how we simplify ratios. So first of all, let's define what a ratio is. A ratio is simply the quotient of two quantities. Very simple definition. And so there's two notations for ratios. And we say the ratio of A to B is expressed by the fraction notation A divided by B, where A is the numerator and B is the denominator, or by the colon notation, A to B. That's how this is read, A to B, when we have the colon there. So let's do that right away for some exercises here. Find the ratio of 5 to 11. We can write it as a fraction notation, 5 divided by 11, or 5 to 11. So it's very simple, very easy. Similarly for exercise number 2, the ratio of 57.3 to 86.1. In fraction notation, that's 57.3 divided by 86.1. And by the way, for the time being, we're not reducing these fractions here. Or 57.3 to 86.1. Now, in number 3, for number 3 we do the same thing. 6 3/4 is the numerator in this expression, and 7 2/5 is the denominator. Or 6 3/4 to 7 2/5. In number 4, it says record snowfall. The greatest snowfall recorded in North America during a 24-hour time period was 76 inches in Silver Lake, Colorado on April 14th to the 15th in 1921. What is the ratio of amount of snowfall in inches to time in hours? So in other words, we're going to write a fraction that says 76 divided by 24. And it's good to remember that the numerator is in inches and the denominator is in hours. And later on we'll pay a lot more attention to these units of measure. But this is the ratio. "76 inches in 24 hours. Number 5 states a 16-ounce coffee mocha with whole milk contains 360 calories, and a 16-ounce iced blended cappuccino contains 240 calories. What is the ratio of the number of calories in a coffee mocha to the number of calories in a cappuccino? Second question, what is the ratio of the number of calories in a cappuccino to the number of calories in a coffee mocha? So for the first question, the number of calories in the coffee mocha to the number of calories in the cappuccino, well, the calories in the coffee mocha is 360, and the number of calories in the cappuccino is 240. The second question, what is the ratio of the number of calories in a cappuccino to the number of calories in a coffee mocha, is just the other way around. The number of calories in a cappuccino is 240, and the number of calories in a coffee mocha is 360. In number 6, we're looking at a triangle, and the question is, what is the ratio of the length of the shortest side to the length of the longest side? Well, we look at the three sides, 55.5 yards, 40.3 yards, and 38.2 yards. So the shortest side is obviously 38.2 yards. So this is for number 6. So the shortest is 38.2, and to the longest side is the hypotenuse. It's 55.5 yards, 55.5. Number 7 is about NBA playoffs. It says, in the final game of the 2017 NBA playoffs, the Golden State Warriors made a total of 67 baskets. Of these, 19 were free throws, 32 were two-point field goals, and the remainder were three-point field goals. So question A is, what is the ratio of the number of two-point field goals to the number of free throws? Well, when you look at the two-point field throws, there were 34. So that's 34 for the number of two-point field goals, the number of free throws, and we are told there were 19 free throws. So it's 34 to 19. And then the next question is, what is the ratio of the number of three-point field goals to the total number of baskets? So the total number of baskets was 67, and the three-point field goals were 14. So for part B, we need to determine the number of three-point field goals. So let's say X is a number of three-point field goals. Then 19 free throws and 34 two-point field goals plus X, the number of three-point field goals, equals a total of 67 baskets. Then X is equal to 67 minus 19 minus 34, or 14. So then the total number of three-point field goals is 14 to the total number of baskets, which is 67. So our ratio is 14 to 64. 67 rather. Next, we'll be simplifying ratios. So here we find the ratio of 3.6 to 12, and then simplify to find two other numbers in the same ratio. The ratio of 3.6 to 12 be 3.6 to 12, and to simplify that, we multiply the numerator and denominator by 10. Then that'll give us 36 divided by 10 times 12, or 120. Then we factor 36 into 12 times 3, and then the 12s cancel. Well, 12 divided by 12 times 3 divided by 10, and so the 12s cancel. That gives us 3 divided by 10. In other words, 3.6 to 12 is equal to 3 to 10. For the next exercise, we have to find the ratio of 18 to 27, and then simplify to find two other numbers in the same ratio. Well, 18 to 27, we can factor that as 9 times 2 divided by 9 times 3, or 9 divided by 9 times 2 divided by 3, so 9's cancel. In other words, this is equal to 2 divided by 3. So we can say that 18 is to 27 as 2 is to 3. The next exercise is quite similar. To find the ratio of 1.2 to 1.5, then simplify to find two other numbers in the same ratio. So it's 1.2 divided by 1.5. When we multiply numerator and denominator by 10, we get 12 divided by 15. We can factor 12 as 3 times 4, and 15 as 3 times 5, and this will then be 3 divided by 3 times 4 divided by 5 equals 4 divided by 5. In other words, 1.2 is to 1.5 as 4 is to 5. The next exercise states that an HD TV screen that measures 44 inches diagonally has a width of 38.4 inches and a height of 21.6 inches. Find the ratio of height to width and simplify. So the height is 21.6 inches and the width is 38.4 inches. We multiply the numerator and denominator by 10 to eliminate the decimals. That gives us 216 divided by 384. And we can factor 216 as 24 times 9, and 384 as 24 times 16. So that'll be 24 divided by 24 times 9 divided by 16, and that simplifies to 9 divided by 16. So the answer is 9 divided by 16. That is a simplified expression of width to height, height to width rather. This is the end of section 5.1.